Okay, so let's do some of these laws of exponents questions together. So A, we've got a fraction, 13 over 2 times 9, all to the power of 2, right? So we've got a fraction that's raised to an exponent. This looks like the law that looks like this, right? A over B to the power of n. And we said when we have this fraction raised to an exponent, we can distribute the exponent to the numerator and to the denominator. So the numerator is raised to the power of n, and the denominator is raised to the power of n. Okay? So what's my numerator in this case? It's 13, right? So the 2 applies to the 13. We get 13 to the power of 2. My denominator is 2 times 9, and that's going to take the power of 2. Okay? We apply it to the top, we apply it to the bottom. So my numerator, 13 to the power of 2, that gives me 169. On the bottom, I have 2 times 9, right? That's a multiplication raised to a power. So that reminds me of my other law, which looks like this, a times b to the power of n. And then in this case, again, we can distribute that exponent to both things being multiplied. That's a to the n times b to the n. So in this case, this is going to be 2 to the power of 2, right? The 2 gets distributed onto that 2, and it also gets distributed onto the 9, okay? And that's going to be 169 over 4 times 81, which is 169 over 324. That's the answer for A. Okay, so B, we've got another fraction that's raised to an exponent, right? So we're going to use this first law that we used before. So once again, what's my numerator? It is 7 times 3. We're going to distribute that 6 onto it. Same deal here. We're going to distribute the 6 to the denominator, which was 5 times 4. Okay, and that's just going to be, well, on the numerator we have a multiplication raised to an exponent, so we can distribute that 6 onto both things. That's going to give me 7 to the 6 times 3 to the 6. In my denominator, I have 5 times 4 raised to the power of 6. So we distribute that 6 again, right? It's this rule that we used before, right? This is this rule here, okay? So we get 5 to the 6 times 4 to the 6, okay? And at this point, you could plug that into your calculator. 7 to the 6 times 3 to the 6. That is going to be equal to 857666121. And in the denominator, we have 5 to the 6 times 4 to the 6. That's going to be equal to 64 million. Okay, and that's the answer for B. Now, notice in question B, right, we had this fraction here. And so after we distribute the exponent to the numerator and denominator, right, so here at this step, we use this second law, right, and we distributed it again because everything in my numerator and denominator are just being multiplied together. And so we distribute it once, we distribute it again, okay? So, you could save some time, okay? Here, I'll write like a bonus tip, okay? If you have something in brackets that's, raised to an exponent like 8, okay? And inside these brackets, there's absolutely no addition, absolutely no subtraction, okay? No addition, no subtraction. But you have multiplication and division. So let's say you have something like, I don't know, let's come up with some random numbers, like 7 to the 3 times x squared over y to the 4 times 5 squared. Okay, random numbers. You see here, there's no addition, there's no subtraction. Okay, so instead of distributing on top and then to the top and bottom, and then distributing again using this law, we can distribute that 8 to everything inside those brackets immediately. Okay, so we put that exponent, that fraction there. Okay, 7 to the 3 to the power of 8, so 7 to the 3 raised to the power of 8. We have to multiply the exponents, right? So that gives me 7 to the 24 times x to the 2 raised to the power of 8. So this is this law here. Let me just write it down, okay, so you're not confused. What I did here for the 7 to the 3 to the 8 to get to that 24, I use this law right here, okay? So a to the n, all to the power of m, right, equals a to the n times m. So 7 to the 3 to the power of 8 is 7 to the 3 times 8, which is 24. Same idea here. I've got x to the power of 2 to the power of 8, right? So that's going to give me 2 times 8 is 16. Now I'm going to distribute that 8 down here, okay? So y to the 4 to the power of 8, that's going to be y to the 4 times 8, that's 32. And here we have 5 to the 8 times 2, or 2 times 8, so 2 times 8 is 16, okay? And so that's kind of like a bonus tip, okay? If you have no addition, no subtraction, just this fraction with multiplication, or if you have just multiplication, or if you just have division, you just distribute that exponent to everything inside of it, okay? By multiplying the exponents, of course, okay? So let's move on to question C. We have a over b to the minus 1, so we can just distribute that exponent to the top and to the bottom, right, to my numerator and denominator. So we get a to the minus 1 over b to the minus 1. I've got this negative exponent up here, right? I don't like that negative exponent. I'm going to bring it from the top to the bottom. That minus 1 is going to change to a positive 1, okay? Now in the bottom, I have another negative exponent. I don't like that negative exponent, so I'm going to bring it from the bottom up to the top. That negative becomes positive. Anything to the power of 1 is just itself, so we get b over a, okay? So we've got 6 to the power of 2 times 6 to the power of negative 5 times 6 to the 3 times 6 to the 8, all of that to the power of negative 3. Okay, so notice that all these things that are being multiplied together all have the same base, right? They have that in common. The base is 6 for all of them. So we can use the law that looks like this, right? The product rule. It's a to the n times a to the m is equal to a, which is the base, n plus m, right? We have two things being multiplied together. They have the same base, so we can add their exponents together. So what do we get here? We get 6 to the 2 minus 5 plus 3 plus 8, and then we still have this down the outside, okay? So 2 minus 5 plus 3, that's just 0, plus 8 is going to be 6 to the 8. All to the minus 3, we have something raised to an exponent that is raised to an exponent. That is this law, right? So that's going to give me 6 to the 8 times minus 3 is minus 24. We have a negative exponent here. We don't like negative exponents. We're going to put that in the denominator. That negative 24 is going to become positive 24. Okay. Now, another way you could have done this question, because you can use different laws depending on what you kind of notice first, right? Notice we have multiplication, and then we have this negative 3 on the outside. That's kind of like the same thing as this bonus tip here that I gave you, okay? Or kind of like this law right here, right? This second law that we used before. We have multiplication, and then outside of that multiplication, we have an exponent. So we're going to distribute that exponent, okay? So you could have also done it this way, where you take that minus 3 and you distribute it to all of the 6's. You're going to get 6 to the 2 times minus 3 is minus 6 times 6 to the positive 15, right? Minus 5 times minus 3. Then 3 times minus 3 is minus 9. And 8 times minus 3 is minus 24. And then if now you notice that they all have the same base. So you're going to use this product rule here, product law. You're going to add their exponents together. That's going to give you minus 24, which once again is just going to turn into 6 to the 24 in the denominator. And you get the same answer. So it doesn't really matter which law you use first or which ones you use. As long as they are correct, they'll simplify down to the exact same answer. Okay? Now, question E. This one looks kind of complicated. Okay? So we've got 3 to the x squared times y over 2 times 19 to the 0. The first thing I'm going to do here, okay, is just get rid of that 19 to the 0. 19 to the 0 is just 1, right? That's just the power of 0 law. Anything to the power of 0 is 1. So 2 times 1 is just 2. So we'll just get rid of that 19 to the 0 right away. We've got this. Now, this is kind of like this bonus tip here, right? There's no addition, there's no subtraction. Okay, all we have here is multiplication and division. We'll just distribute this minus 3 to everything inside these brackets by multiplying that minus 3 to their exponents. Okay, and remember, if there's no exponent here, that just means they have exponent 1, right? 3 to the 1, y to the 1, 2 to the 1. Okay, so let's do that. We don't even need brackets for this. We're going to distribute that minus 3. Okay, so 3 to the 1, right? To the times minus 3. 1 times minus 3 is minus 3, right? X to the power of 2 to the power of minus 3. 2 times minus 3 is minus 6. Y to the 1 to the power of minus 3. 1 times minus 3 is minus 3. Down here we've got 2 to the 1, right? Times to the power of minus 3. 1 times minus 3, I mean, is minus 3. Okay, so we put this fraction line here. Let's look at this. 3 to the power of minus 3. There's a negative exponent there. We don't like negative exponents, so we're going to take that from the numerator, okay, push it down to the denominator, flip it down here, okay, and that negative is going to turn positive. Same deal here. We've got x to the minus 6 in the numerator. We don't like that negative exponent. Put it in the denominator, change that to a positive 6. Same with the y to the minus 3. And down here, we've got 2 to the minus 3. We don't like that negative exponent, so we're going to put it from the bottom up to the top. It's going to flip on over to the top. This minus 3 becomes positive 3. And so that's going to give me 8 over 27 x 6 y 3. Okay. F. So we've got this thing in brackets, right? This fraction, all to the power of minus 4. This is the same idea as when we use that bonus tip, right? So because there's no addition, no subtraction, we can take that minus 4 and distribute it to everything on the inside by multiplying that minus 4 to their exponents, okay? So that's going to give me 8 to the 1 times minus 4 is minus 4, okay? 3 to the minus 4. A to the 2 times minus 4 is minus 8. We have a bunch of negative exponents. So let's put that line here, right? What is, well, 8 to the minus 4. What do we do with that? How can we deal with that negative exponent? Because we don't want a negative exponent. We want to turn that positive. Well, it's in the numerator, so we're going to flip it down to the denominator, and that minus 4 is going to become positive 4. Here, we've got 3 to the minus 4, negative exponent in the denominator. We don't want it here, okay? We don't want that negative exponent, I mean. So we're going to move it out of here to the top, flip it on over here, and that negative 4 is going to turn into a positive 4, okay? Same idea here. Move it up to the top, change the sign, okay? And now all we have to do is find out what these numbers are. 3 to the 4 is 81, 88, and 8 to the 4 is 4096, if I recall correctly, okay? Now G, we've got this fraction here that's inside brackets raised to an exponent. So that's just the same law as this one, right? A over n, A over b, I mean, to the n. So that's going to be equal to a to the n over b to the n, right? We just distribute that n up and to the bottom. So we're going to get what? 8 to the 1 times 2 is 2. 5 to the 5 times 2 is 10, times 8 to the 3 over 5 to the 4. So we've got two fractions being multiplied together. Remember that to multiply fractions, right? Let's say we have something like a over b times c over d. We have two fractions being multiplied. All we do is multiply the numerators, divide that by the multiplication of the denominators, okay? A times c, b times d. All right, so that's going to give me 8 to the 2 times 8 to the 3, right? Top times top, bottom times bottom, 5 times 10 times 5 to the 4. Now we can use this rule here, right? A to the n times a to the m is equal to a n plus m, right? Same base here, same base here. We're just going to add their exponents together. We get 8 to the 2 plus 3 is 5. 5 to the 10 plus 4 is 14. And that's the answer for G. And if you really want to, if it fits in your calculator, of course, you can write this as well as 32768 over 61035 15625. Okay, you can also write it this way as well. Okay, so H, we've got actually this is just exact same question, so we could just skim on over this one and we'll go straight to I. Okay, so we've got a fraction raised to an exponent, same deal as when we use that bonus tip. Okay, if you kind of skip that bonus tip, it's this right here. Okay, so if you have something raised to an exponent and everything inside those brackets, you know, have no subtraction, no addition, it's all a fraction or just multiplication. Okay, you can just distribute that exponent to everything inside by multiplying it to the exponents. Okay, so here we've got 3, 4 times 3 is 12, times 8 minus 2 times 3 is minus 6. Here we've got 3 to the 3 times 3 is 9, times 10 to the 2 times 3 is 6. Okay. Here, notice we've got 3 to the 12. Down here, we've got 3 to the 9. So that's going to be this law right here, right? We've got a to the n over a to the m, right? We've got something in the numerator, something in the denominator. They have the exact same base, okay? So all we're going to do is take the exponent from the top, from the numerator, and minus the exponent in the denominator. Okay, so 3 to the 12 over 3 to the 9, right? Imagine you like kind of block off this side and just look at this fraction alone. Okay, so 3 to the 12 over 3 to the 9, we just write 3 to the exponent of the numerator, which is 12, minus the exponent in the denominator, which was 9. Okay, times 8 to the minus 6 over 10 to the positive 6. Okay, so that's 3 to the 3 times 8 to the minus 6 over 10 to the 6, which is 27 times 8 to the minus 6 over 10 to the 6. Now, we've got a negative exponent here, right? I don't want a negative exponent. So the negative exponent is at the top in the numerator. To turn that positive, we're going to take it from the top, flip it down to the bottom, and change the sign from negative to positive. That's going to be 8 to the 6 times 10 to the 6. And that's my answer for I. Okay, J. So, same as before. There's no subtraction or addition here. So we're going to distribute that exponent to everything inside by multiplying the exponents together. So on top, we've got base 7. 4 times 3 is 12, times base is 2, minus 2 times 3 is minus 6. 4 to the 3 times 3 is 4 to the 9, times 13 minus 5 times 3 is minus 15. Okay, so let's draw a little fraction here. Here we have a positive exponent, so we'll leave it where it is. Here we have another positive exponent, we'll leave that where it is. Okay. Now, this 2 to the minus 6 has a negative exponent. It's in the numerator. We don't want a negative exponent, so we're going to take it from the numerator, flip it down to the denominator, and change that negative 6 to a positive 6. Okay? This negative exponent, 13 to the negative 15, right, is in the denominator. So we're going to take it from the denominator, flip it to the top. That's going to go 13 to the positive 15. Okay? And I think we could just leave that as it is. If we try to calculate that, it's not going to fit in your calculator anyway. All right, so K. We've got two kind of fractions here that are being multiplied together. right? And each of these fractions are being raised to an exponent. So one way we could start this question, right, is by using the shortcut or that bonus method that I taught you guys earlier in this video. You could just take that exponent and distribute it to everything in the fractions, because there's no addition, there's no subtraction, and you just multiply that exponent to all the other exponents inside those brackets. So that's one way you could do it, and if you carry out all your work correctly, you'll get the right answer. But that seems like a lot of work, right? So if you just take a second and look at this question real quick, right, you'll notice that here you have 3 to the 5, and here you have 3 to the 4, which are the same base. Here you have x to the 0, which you could just call as 1, right? And here you have 2 to the minus 2, and here you have 2 to the minus 7, which have the same base. So there's some kind of simplification that we can do before we even distribute this exponent here, okay? Of course, like I said before, if you want to jump straight to distributing the exponent, go for it. You'll get the right answer anyway. Just seems like a lot more work, okay? So at the top, we still have 2 to the 3. Now, we're going to use that rule here, right? We have the same base, one on top, one on bottom. So 3, what was the rule? It was a to the n over a to the m is equal to a to the n minus m, right? If you have something divided by something else that has the same base, we subtract the exponent. So we take the exponent on the top minus the exponent from the bottom. So my base was, what, 3 here? The exponent on top is 5. The exponent on bottom is 4. And all that's left on the bottom is my x to the 0, which, anything to the 0 is 1. So we'll just call this 1. And you know what? Anything divided by 1 is just itself. So we'll just get rid of that completely. We just have 2 to the 3 times 3 to the 5 minus 4 to the power of 2 times 3 to the 3. And same rule as before, right? 2 to the minus 2 over 2 to the minus 7. We can just subtract the exponents. So this is 2 to the minus 2 minus 7, all to the power of 3. So this is 2 to the 3 times 3 to 5 minus 4 is 1. So 3 to the 1 is just 3. This is all to the power of 2. 3 to the power of 3 is, well, I'll just leave that as 3 to the 3 for now. Okay, times 2 minus 2, well, 2 to the minus 2 minus 7. Minus is positive, it's plus. So minus 2 plus 7 is 5, all to the power of 3. And now at this point, we can use this rule here, right? The a times b to the n is equal to a to the n times b to the n, okay? Or you could call this the shortcut method as well, okay? There's no addition, no subtraction, so we could just distribute the exponent by multiplying it to the exponents of everything inside. So 2 to the 3 times 2 is 6, times 3 to the 1 times 2 is 2, times, here we've got 3 to the 3 times 3 is 3 to the 9, times 2 to the 5 times 3 is 15. So we have 2 to the 6 times 3 to the 2 times 3 to the 9 times 2 to the 15. Notice here we have multiplication of the same base, right? 3 and 3. Here, these 2's are also being multiplied, right? This whole thing is being multiplied together. So same base here is a 2. Same base here is another 2. So we can just we multiply them together by adding their exponents together, right? Adding the exponents. So let's start with 2 because it's a smaller number. We got 2, add 6 and 15. That's going to be 21, right? And here we've got 3 to the power of 2 plus 9. 2 plus 9 is 11. So 2 to the 21 times 3 to the 11. And maybe just so you guys can understand, I'll write this here. A to the n times a to the m is equal to a to the n plus m. Okay, that's the rule that I used. That's the law that I used, I mean. Okay? Now, let's look at L. So to start L off, I'll notice that here we've got 4 to the 2, and here we've got 4 to the 1, right? So we can just use this kind of division rule that we had before, where we had, what was it? a to the n over a to the m is equal to a to the n minus m, right? So that will help simplify, I guess, a tiny bit. So we got 7 to the 5 times 6 to the power of 2 over 3 to the power of 2 times, here what do we have? We have 4 to the 2 minus 1 times 3 to the 3 over 6 to the 3 times 7 to the 4, all to the power of 2. Okay? Oh, and here we have minus 3. Okay. So at this point now, okay, 2 minus 1 is just 1, and 4 to the 1 is just itself. Okay? At this point now, we can distribute using that bonus tip that we used before. Just multiply this exponent to everything inside. Same deal here, right? There's no addition, there's no subtraction, so we can use that bonus tip. This is going to give me what? 7 to the minus 15 times 6 to the minus 6 over 3 to the minus 6 times 4 to the 2 times 3 to the 6 over 6 to the 6 times 7 to the 8, right? I just multiplied all of the exponents to 2, and for this one I multiplied all the exponents to minus 3 because I just distributed those exponents, okay? And so now here we've got a negative exponent on the numerator, another negative exponent in the numerator, so I'll just bring them both down to the denominator and switch those negatives to positives. Here we've got a negative exponent in the denominator, so I'm going to bring it up to the top and switch it to a positive. And here we've got 4 to the 2 times 3 to the 6 over 6 to the 6 times 7 to the 8. Okay? I'm kind of running out of room here. Let me just scooch this a little lower. Okay. So at this point, remember to multiply two fractions together, right? We just multiplied the numerators together. We multiplied the denominators together. So we have 3 to the 6 times 4 to the 2 times 3 to the 6 on the top, divided by 7 to the 15 times 6 to the 6 times another 6 to the 6 times 7 to the 8. And notice here we've got the same base, right? 3 and 3. And here we've got 7 and 7. Here we've got 6 and 6. So remember when we multiply two things with the same base, we multiply them together by adding, right? Remember, adding their exponents. So we've got 3 to the 6 plus 6 is 12 times 4 to the 2 over 7 to the 15 plus 8 is 23 times 6 to the 6 plus 6 is 12. Okay, and I'm pretty sure this won't fit in your calculator either, so you can just put this in a box. And that's that for question L. All right, so let's look at M, right? To start M off here, okay, instead of taking this 3 and distributing it using that bonus tip that we had before, and same thing here with the minus 4, right? Notice here we have 5 to the 3, here we have 5 to the 2, here we have 5, we'll call that 5 to the 1, okay? And here we've got, well, these things don't really matter here for now, okay? So notice here we have a bunch of base 5s, right? And so instead of distributing this right away, seems like a lot of work to, a lot of things to distribute onto, right? What we're gonna do is we can simplify this by using this rule here, right? A to the n times a to the m. We've got two things being multiplied together. What do we do with their exponents? We add them, right? So in the numerator here, we've got 5 to the 3 times 5 to the 2. So we're multiplying them together by adding their exponents, okay? And then here we still have 5 to the 1, x, 3, y to the 4, all to the power of 3, times x to the 5 times y squared over 5 squared, all to the minus 4. Okay, so here we've got, well, let's just write this here. 3 plus 2 is 5. Okay. So 4 squared times how much? Well, remember, this is 5 to the 5. Here we have 5 to the 1. So 5 to the 5 over 5 to the 1, right? What is that? Well, a to the n over a to the m is equal to a to the n minus m, right? When we multiply two things with the same base, we add their exponents, right? if we divide two things that have the same base, we subtract the exponents, right? Numerator minus denominator. So in the numerator, my exponent was 5. In the denominator, it was 1. 5 minus 1 is just going to be 4. Okay? And here I've got x cubed y to the 4 all to the power of 3. Here I've got, well, let's distribute this minus 4 now, right? How do we distribute the minus 4? Well, we just multiply it to all of the exponents, right? Make sure first to look at the fact that there's no addition, no subtraction in these brackets. So we'll just distribute that exponent. We get x to the 5 times minus 4 is minus 20 times y to the 2 times minus 4 is minus 8. All over 5 to the power of 2 times minus 4 is also minus 8. Okay. So, and actually we don't even need these brackets anymore. We'll get rid of those. Okay. Now, we can distribute this 3 because there's no addition, there's no subtraction in here, right? So we multiply all of the exponents by 3. So 4 to the 2 times 3 is 6, times 5 to the 4 times 3 is 12. Here we've got x to the 3 times 3 is 9, times y to the 4 times 3 is 12. And then here we've got x to the minus 20, y to the minus 8. Actually, let's not write it this way. We have negative exponents, right? We have negative exponents. We don't like negative exponents. Let's get rid of them. Here we've got x to the minus 20 in the numerator. So we're going to bring it to the denominator here and change that minus 20 to a positive 20. Same deal here. We've got y to the minus 8. That's a negative exponent. We don't want this here. We're going to flip that down to the bottom and change that minus 8 to a positive 8. And here we've got 5 to the minus 8 in the denominator. We're going to flip that up to the top and change that minus 8 to a positive 8. Now, how do I multiply these two fractions together? Well, we're just going to take all of the numerators and multiply them together. All of the denominators, multiply them together. So 4 to the 6 times 5 to the 12 times 5 to the 8 over x to the 9 times y to the 12 times x to the 20 times y to the 8. So all of these things are being multiplied together. All of these things are being multiplied together. Okay? Notice here we've got a base of 5. Here we also have a base of 5. So when we have two things that are the same base, we can multiply them together by adding their exponents, right? That's what this law tells me. So 4 to the 6, these two things, we multiply them together by adding the exponents. We have 5 to the 12 plus 8 is 20. Same idea down here. We have x to the 9, here we have x to the 20. They're being multiplied together, right? All of these things are being multiplied together. Doesn't matter that they're not next to each other. So 9 plus 20 is 29 times y to the, here I have y, here I have another y, 12 plus 8 is 20. Okay? And this is your final answer. Now, some of you might be looking at this and wondering, well, maybe at this step here, right? Let me scooch this down a little bit. Maybe at this step here, I don't flip my fraction, right? I don't flip this to the bottom. I flip this to the bottom and flip this up to the top because of the negative exponents. What if I didn't move this down, move this down, move this up, right? What if I just left as it is and then used these laws to keep simplifying? And would I get the same answer in the end? And the answer is, yeah, absolutely you would, right? As long as the laws that you're using make sense, you would get back to the same answer. So let's pretend for a second that we didn't flip this to the bottom, flip this to the bottom, flip this up to the top. Let's keep them exactly where they are, okay? So from this step onwards, let's pretend we don't flip this down, flip this down, flip this up. So we're going to distribute this 3. Okay, let me put a little line here. We're going to distribute this 3 to everything inside, right? We get 4 to the 6 times 5 to the 12 over x to the 9 times y to the 12. And here we have what? X to the minus 20, y to the minus 8 over 5 to the minus 8. So we multiply the numerators together, we multiply the denominators together, right? Instead of rewriting everything, you could just like connect these two fractions here and just put a multiplication sign, okay? So we multiply the numerators together, multiply the denominators together, right? So what do we notice here? We have 4 to the 6, right? Here we've got 5 to the 12. In the denominator, you have 5 to the minus 8. So what do? Well, we have a base on top. We have the same base at the bottom. We subtract the exponents, right? We take the exponent in the numerator minus the exponent in the denominator. So 5. The exponent in the numerator was 12. The exponent in the denominator is minus 8. Okay, let's keep going. We've got x to the minus 20. We have x to the 9 in the denominator. So same as before, we're just going to subtract the exponent in the denominator. In this case, it's 9. Okay, times y to the same idea. We have y on top, y on the bottom. We have y to the minus 8 minus the exponent in the denominator, which is 12. Okay, that gives me 4 to the 6 times 5 to the, what's 12 minus minus 8? Well, we have two minuses. Those two minuses together become positive, becomes a plus sign, right? So 12 plus 8 is 5 to the 20. Here we've got x to the minus 20 minus 9. Minus 20 minus 9 is minus 29. And here we've got minus 8 minus 20. So that's going to be minus 20. Now, this is a positive exponent. That's a positive exponent. So they stay exactly where they are. But here I have a negative exponent. I don't want my negative exponent. I want to make it positive. How do I do that? I put it in the denominator and change that negative to a positive. Same deal here. I have a negative exponent. I don't want a negative exponent. I'm going to put it in the denominator and change that negative to a positive. Okay? And notice these two answers, let me scroll up a bit so you can see the exponents. These two answers are exactly the same. Okay? As long as you use your laws of exponents in the correct manner, okay? It doesn't matter which ones you use, as long as they're right, given the context, you'll get the exact same answer once you simplify, okay? So, question N. We've got two fractions being raised to different exponents, right? And they look kind of, complicated, but here we've got three things that are base 2, right? They all have the base of 2. So let's remind ourselves of what laws we can use with base 2, right? Or with the same base, So a to the n times a to the m is equal to a to the n plus m. And a to the n over a to the m is equal to a to the n minus m, right? When we multiply two things with the same base, we add their exponents. When we divide two things with the same exponent, we subtract their exponents, okay? So here we've got 2 to the 4 times 2 to the 3, so we add their exponents, 4 plus 3, okay? Now, we can finish writing everything out, right? But we know in my next step anyway, we're going to have to use this 2 to the 4 plus 3, which is 7, right? 2 to the 7, and divide that 2 to the 4. So next step, we're going to be dividing these two things by subtracting their exponents. So I may as well just do this all in one step here, right? Bonus trick here, okay? We multiply this, then we divide that, we do it all in one step, okay? And then here we'll have 11 to the 8. And at the bottom we have 8, a to the minus 6, all to the power of 2, times 11 to the 5 times 2 to the 2 over a to the 2 to the minus 4. Okay, 4 plus 3 is 7, minus 4 is 3, so this is just 2 to the 3, okay? Now, we can take this 2, right, use my bonus tip like before. There's no addition, no subtraction here. We're just going to distribute that 2 to everything inside by multiplying it to their exponents, right? Same thing here, minus 4, right? We're going to distribute it to everything inside by multiplying minus 4 to all of the exponents on the interior, because there's no addition, there's no subtraction. So here we've got 2 to the 3 times 2 is 6, times 11 to the 8 times 2 is 16, over 8 to the power of 1 times 2 is 2, a to the minus 6 times 2 is minus 12, okay? And here we've got 11 to the 5 times minus 4 is minus 20, times 2 to the power of 2 times minus 4 is minus 8, over a to the 2 times minus 4 is minus 8. Okay. And now to multiply two things together, right? Two fractions together, I mean, we're just going to multiply the top and bottoms together. So numerator, numerator, denominator, denominator. We're just going to merge these two fractions and add a multiplication sign here, okay? So all the things on top are being multiplied together. All the things on the bottom are being multiplied together. So let's start with the 2, because that's the first thing here. We got 2, and it's being multiplied to this thing here. We've got 2 to the minus 8. So we're going to add the exponents together. So 6 minus 8. Okay? Here we've got 11 to the 16 times 11 to the minus 20. We're going to add the exponents together. 16 minus 20. Okay? Here we've got 8 to the power of 2 times 8 to the minus 12 times 8 to the minus 8. We're going to take minus 12 and add that to minus 8. So plus minus 8 is just the same thing as minus 8. Okay? Because plus and minus, positive, negative, turns into negative. So plus minus 8 is just the same thing as minus 8. So on top, we've got 2 to the 6 minus 8 is minus 2 times 11 to the 16 minus 20 is minus 4. Over here, we've got 8 to the power of 2 is 64. And a to the minus 12 minus 8 is a to the minus 20. All right. So 64 has a positive exponent, right? It's an exponent of 1. So we're just going to leave that as 64 in the bottom. Okay. 2 to the minus 2 is a negative exponent. I don't want a negative exponent, so I'm going to bring it from the top to the bottom and change that negative 2 to a positive 2. Same idea here. We've got negative 4 in the numerator. Bring it to the bottom. It's going to be 11 to the positive 4. And same idea here is at the bottom. We're going to bring it up to the top. It's a to the positive 20 now. Okay. And I guess here you can, if you really want to, okay, 64 times 4 times 11 to the 4. And yeah, this is 256. All right, and that should be your answer for n. Question O. So we've got this fraction here raised to an exponent, this fraction here raised to an exponent. So let's start off here. Let's simplify what's inside of these brackets. So we've got 3 to the 7 times 3 to the 2. Because it's the same base, we can just add the exponents, right? 7 plus 2 times 6 to the 3 over 3 squared a to the 6 b to the minus 4 all to the power of 2 times, I don't know what happened here, this is 6. Okay, here we've got 6 to the 4 times, what's 3 to the 0? That's just 1, right? We've got 6 to the power of 1 times a to the minus 3, b to the 3, all to the power of 5. Okay. So here we've got 3 to the 9, right? 7 plus 2 is 9. At the bottom, we have the same base, right? Base 3, right? So same base on top, same base on the bottom. We're going to subtract the exponent now. So 3 to the 9, right? 7 plus 2 is 9. Subtract that 2, right? Same base, one on top, one on bottom. We subtract the exponents. Here we've got 6 to the 3. At the bottom, we have a to the 6. Here we have b to the minus 4. Okay, well, I don't want this down here, so I'm going to move it up to the top. Change that to a positive 4. Okay. If you didn't flip it to the top and you only flipped it later after you distributed that 2, absolutely fine as well. Okay, like I said, there's no real order that you need to do these laws of exponents in. As long as they make sense when you do them, okay, you'll get the same answer at the end anyway. So here we've got 6 to the 4 times 1 is just 6 to the 4. Here we have 6 to the 1 at the bottom. So we have the same base. So we're going to take the base to the power of the numerator minus the 1 in the denominator. Okay, here we have a to the minus 3. So a to the minus 3, same idea. We're going to bring it up to the top, change that minus 3 to a positive 3. Here you have b to the 3, all to the power of 5. Okay. Now, at this point, we can distribute the exponents to everything on the inside. All right, so this 3 to the 9 minus 2, maybe I'll write that as 3 to the 7. And 6 to the 4 minus 1, maybe we can write that as 6 to the 3. Okay? So how do we distribute this? First, we have to check that there's no there's no addition or subtraction, right? In either of these cases, there's no addition, no subtraction. So we're just going to distribute it by multiplying the exponent to the exponents on the inside. So 2 times 7, 2 times 3, 2 times 4, 2 times 6, 5 times 3, 5 times 3, and 5 times 3 again. So we get 3 to the 14 times 6 to the 6, b to the 8 over a to the 12 times 6 to the 15 times a to the 15 over b to the 15. Now we have two fractions being multiplied together, so we're just going to multiply the numerators together, multiply the denominators together. All right? So that's going to give me what? We've got 3 to the 14. Up here we've got 6 to the 6. Here we've got 6 to the 15. So same base, we can add their exponents together. 6 plus 15 is 21. Here we've got b to the 8 times a to the 15 over a to the 12 times b to the 15. All right. Now, we've got b on top, b on bottom, a on top, a on bottom. We just subtract the exponents, right? Exponent from the top minus exponent in the bottom. So b to the 8 minus 15 times a to the 15 minus 12, right? 8 minus 15 is just going to be minus 7, and 15 minus 12 is just minus 3, right? So at this point, not minus 3, positive 3. I can't do math. Okay. So at this point, we can just write 3 to the 14 times 6 to the 21. Uh-oh, b to the minus 7 is a negative exponent. So we're going to flip that onto the bottom here and change that minus 7 to a positive 7. And here we've just got a to the positive 3. So that is your answer for question O. Okay. All right, so question P. What do we have? We've got 8 to the power of 2. At the bottom, we have 8 to the power of 1, right? So 8 squared divided by 8 to the power of 1. We just subtract the exponents, right? Same base here. Okay, we have y to the minus 3 and x to the power of 2. And that's all raised to the power of 2, negative 2. What do we have here? We've got 3x to the 5, y to the power of 2, all over 8 to the power of 0 is just 1 times 8 to the 4. We'll just write that as 8 to the 4. Okay? And that's all raised to the power of minus 3. Now, 2 minus 1 is just 1. All right? So 8 to the power of 1 is just 8. So at this point, we can distribute that minus 2 to everything. We get 8 to the 1 times minus 2 is minus 2. Y to the minus 3 times minus 2 is positive 6, right? Minus 3 times minus 2 is positive 6. The bottom here, we've got minus 2 times minus 2, right? Minus 2 times minus, 2 times minus 2, I mean, is minus 4. Here we've got, we're going to distribute that minus 3 onto everything by multiplying it to their exponents. We've got 3 to the minus 3, x to the minus 15, y to the minus 6, and 8 to the minus 12. Okay? Now we're multiplying two fractions together, so we multiply the numerators together, multiply the denominators together. We get 8 to the minus 2. Notice in the denominator here I have 8 to the minus 12, so we can subtract that exponent, right? Same base here. We've got y to the 6. We've got y to the minus 6 here. So same base, we'll just add their exponents together, right? 6 plus minus 6. Here we have 3 to the minus 3. We have a negative exponent. I don't want that negative exponent, so I'm going to flip it on to the bottom here. Okay? So 3 to the positive 3 now. And here we have x to the minus 15. And we also have x to the minus 4 in the denominator. So we're going to subtract that minus 4. Okay? And so that gives me 8 to the minus 2 minus 12. So minus 2 plus 12. So that's 8 to the power of 10 times y to the 6 plus minus 6 is 6 plus and minus become minus. So 6 minus 6 is 0. right, times x to the minus 15 minus minus 4. Minus and minus become positive, so minus 15 plus 4 is minus 11 over 3 to the 3 is 27. Okay, and so that's going to give me 8 to the 10. Y to the 0 is just 1, right? So we don't have to write that. And x to the minus 11, we have a negative exponent, so we're going to bring that down to the bottom and change that to a positive exponent. All right, so the last question here, question Q. All right, so what do we have? We have 6 times x squared, right? And here we've got, at the bottom, x to the power of 3. So we have x to the 2. Here we have x to the 3. So numerator, denominator, we have the same base here. So we just take the exponent on the top minus the exponent on the bottom. Times 3y to the minus 3 all over 2. We don't have to write that x cubed again. We already took care of it, right? And here we have minus 3 times 2y squared. We have a y up here. We have another y down here. So same base, right? One on top, one on bottom. So we take the exponent from the top minus the exponent from the bottom. Okay, 4x minus 3 all over 5. We don't have to write that y squared again. We already took care of it. And that's all raised to the power of 2. All right, so that's going to give me what? That's going to give me 6x to the minus 1 times 3 to the minus 3 times y to the minus 3 over 2, all to the power of minus 3, times 2y to the 0 times 4x to the minus 3 over 5, all to the power of 2. Okay, and let's continue on the next line here. Okay, so here we can distribute that exponent of minus 3 by multiplying it to the exponent of everything inside. So that's going to give me 6 to the minus 3, x to the minus 1 times minus 3 is positive 3, times 3 to the minus 3, y to the minus 3 times minus 3 is positive 9 over 2 to the power of negative 3 is, oh yeah, 2 to the negative 3, okay? And here we've got 2 times y to the 0 is just 2 times 1 is just 2, times 4 times x to the negative 3 over 5, all to the power of 2. All right, so we've distributed this negative 3. Let's distribute that 2 as well. All right, so we've got 6 negative 3, x 3. Okay, well, actually, on this side, let's just do some simplification, right? We've got negative exponents. So negative exponent here. Let's bring that down to the bottom. Okay, and flip its exponent. Here we've got x cubed. Here we have another negative exponent. Let's put that down to the bottom here. Okay, and y to the 9, that's going to stay up here. And here we've got 2 to the minus 3, negative exponent. Bring that up. Flip its exponent to a positive. Okay, to the 2 to the 3, not 2 to the 0. Positive 3. Okay. Times. And here let's distribute the exponent of 2. So we've got 2 squared times 4 squared times x to the minus 6 over 5 to the 2. Okay. And now we can multiply these two fractions together by just multiplying the numerators together, multiplying the denominators together. Okay, that's an awful looking line. Let me just erase that and make just one good line here like this. Okay, that's as good as it gets. All right, so in the numerator we have x cubed, we have x to the minus 6, so they're being multiplied together. They have the same base. We just write 3 minus 6. Okay, we put their exponents together, we add the exponents together. 3 plus minus 6 is 3 minus 6. Okay, here we've got y to the 9, right? Then we've got 2 to the 3. Here we've got 2 to the 3. Here we have 2 to the 2. So same base. We just add their exponents together because they're multiplying together. We have 4 to the 2. And at the bottom, we've got 6 to the 3 times 3 to the 3 times 5 to the 2. And that's going to leave me with x to the minus 3 times y to the 9 times 2 to the 5 times 4 to the 2 over 6, 3 times 3 to the 3 times 5 to the 2. Okay? And because I have that x to the negative 3, I will just flip that down to the bottom as x to the positive 3. And that's going to be all for question Q. And so we're just going to put that in a box. And if you have any questions, just leave them in the comments below. And apart from that, have a great day. Bye, everyone.